All right, so permutations, combinations. Let's see if I can add a bit of table of some sort, maybe just some lines in here. So the first one here is, okay, the first one I want to look at is we have a permutation, all right, and in particularly we have a permutation with repetition. Okay, so yeah, permutation with repetition. But first, let's look at the concept of a permutation. What does permutation actually mean? Whenever you see the word permutation, and it's part of the subject called counting methods. So permutation is basically some kind of calculation. By definition, a permutation is a mathematical calculation. So it's a calculation giving us the total number of ways. Okay, giving us the total number of ways a particular set can be arranged. A particular set can be arranged. Yeah, yeah, yeah. So the other possibility is, suppose you're given set A, and set A is given by two elements, 1 and 6, and you want to find the permutation of set A. So then you want to find out all the different possible combinations of set A, which means your permutations will be 1 and 6, 6 and 1. And those are the total possible arrangements of 1 and 6. So basically, we have two ways to do that. And now, permutations can be divided into different parts. The first one is a permutation with repetition. So when you get a permutation with repetition, we basically make a note here to state that when we permutate with repetition, we use permutation formulas when order matters. All right, so this is when the order of how you arrange it matters, when order matters. And the formula for permutation with repetition is also very specific. The formula is n to the power of r, and it basically states that when n objects or n things that I'm choosing from, I want to choose r of them. Okay, so given n number of things, choose r from them. An example would be, so let's suppose you got a password that is, let's say, 5 digits, and each digit is from 0 to 9, and the digit can be repeated. So you're given that as information. And the question says, how many different codes can you have? And so the answer for this comes to, firstly, n is equal to 10 and r is equal to 5. So it'll be 10 to the power of 5. And that's how many different codes you can get for that. So given 10 codes, I want to choose 5 from there. So we're going to have possibilities of 10, because from 0 to 9, we have 10 options. Yeah. So we have 5 digits, 1, 2, 3, 4, 5. Each digit has 10 options. And so we're technically multiplying each of the options by each other to get the total possible options for that. So in this instance, the order matters. So this is when order matters. When order does not matter, that's when we use a combination. It depends how you look at it. So, all right, so the next type is a permutation without repetition. So for this one over here, we want to remove the repetition. So order still matters, right? So when order matters, and in particularly for this case, we want to remove the repetition. So in the previous case, we'd have repeated values, but now we want to remove it from there. Okay, so the formula in association with this is the following. So the formula is given as n factorial divided by n minus r factorial. And what this actually means is that when n number of things are chosen from, okay, so when we choose from n number of things, we choose r of them, so we end up showing that the permutation is given by npr, or sometimes npr like that, which is given by n factorial over n minus r factorial. Now, let's look at an example of this one as well. All right, so example of this one would be something like this. How many ways can you order 3 out of 16 different pool balls? So here we're given n is equal to 16 and r is equal to 3. So we got 16 factorial divided by 16 minus 3 factorial. And that's the same as 16 factorial over 13 factorial. And what you'll notice is that if we have to calculate this, yeah, so 16 factorial is given by 16 times 15 times 14 times 13 times 12, and it continues all the way until 1. And then 13 factorial, if I start over here, is 13 times 12 times. So what ends up happening is that these cancel out, and it's basically 16 times 15 times 14. Now, what does this also mean if you look at it in a different way, right? If you look at it in a different way, what we're actually seeing here is that how many ways can you order 3 out of 16 different pool balls, which means that if you have 16, right, you can order them in 16 ways, all right? Order 3, okay? So the second ball, the first ball has been removed, so now you got 15 left. The second ball has been removed, so now you got 14 left. And then you got 3 balls in total, 3 out of 16 different pool balls. And they're using the word different as well. You're not putting it back. All right. In how many ways can you order 3 out of 16 different pool balls? It would be that. The other option now would be if you put it back and there is repetition, then that would be 16 times 16 times 16, which is 16 cubed if you had to order it putting it back, which was the previous with repetition example. Yeah. Different means without repetition. Yeah. If you look at the previous example, the password for 5 digits, each digit, every time you choose a digit, you had 10 options and the options didn't reduce. So because you could repeat the numbers, it means that you kept your 10 options all the way through and multiplied them. Whereas without repetition, if that was the case, then we could not have the same number twice. So we had to choose from 10 numbers, then choose from 9 numbers, then choose from 8, then from 7, then from 6. And then it would be a specific, a more limited approach. And we can rewrite that. We're rewriting that as 16 factorial in this case divided by 3 factorial. You can also look at it as the total number of ways of arranging all of them and reducing that sample space by 3. So removing 3 or dividing it into the what we're doing by canceling it out, we are decreasing the total number of ways considerably because we're only choosing 3. Yeah. Yes. So 16 cube is 4096, which is more than 16 factorial divided because here you're reducing that amount by that. All right. So now we're going to be moving into the next thing now. Yeah. So next one now is combination. All right, let's have a look at combinations with repetition. So in this one here, order does not matter. Okay. And the formula in place for this is given by n factorial over r factorial divided by n minus r factorial. So if we choose, yeah, r, let's say items from n number of items or n number of things, then this is what we follow. We also use by notation C and R, C with the N at the back, R at the bottom, or C with N at the bottom, R at the bottom. Or we also write it like this as a column vector. So NCR and as n factorial over r factorial multiplied by n minus r factorial. And let's have a look at an example of this one now. An example of this. So this is an n number of things with repetition. All right, I just need to double change this. This one is the one without repetition. not with repetition. Without repetition, when order doesn't matter. An example would be the state. Let's say you have some kind of, let's say you want to play the lottery, you play the lottery, and you can choose numbers between 150, 1 and 50. Choose between my base numbers from 1 and 50. All right, to determine the winning numbers. So you got total of 50 options there. And so that's going to be n, right? So n will equal 50. And whenever you play the lotto, you choose 6 numbers. So r will be equal to 6 for this. So when you substitute it in, what you end up having is 50 factorial divided by 6 factorial multiplied by 50 minus 6 factorial. And you can see that over there is NPR, your permutation. So technically what you're doing is you're actually taking your permutation in PR and you're dividing it by 6 factorial. Further, yeah, because in this case, you're going to end up with 50 times 49 times 47. So if we write it out manually, so technically that's going to cancel out over there. But then you're still dividing this by 6 times 5 times 4 times 3 times 2 times 1 after you've canceled that part out from there. So you play the lottery, you choose between 50 numbers, all right? But then at the same time, you can choose these 6 numbers. So if you got basically, you play the lottery, you choose between 1 and 50 numbers. So you have 50 ways of choosing the first number. Then you have 49 ways of the second, 48 of the third, 47, and then 46. It's supposed to be going up to 44. Yeah, it's supposed to be going up till 44. So let me just erase that. So this was supposed to be going up to 4, which means that's not supposed to cancel out. Only cancels out from 44 onwards. So we're keeping that. 45 we keep there. It's from 44 onwards do we cancel it out. And that, because this is 44 factorial. That would be over here. It's 43, etc. So those will cancel out on that end of the spectrum. Okay, so let's just erase that. Leaving me with 50 times 49 times 48 times 47 times 46 times 45 times 44 options of choosing that. So on the calculator, you would type 50, then you press that button, shift, and you'll see C and then 6. So that's right, 50C6. And it will give you the value of 15,890 700. So not 15,000, 15,890,700 combinations. And those are the total number of ways of having that from there. If you're asked to find the probability, yes, then that would be one out of that possibilities. Yeah, so the top part gets to that using this over here. Now notice we're dividing by 6 factorial as well. So looking back at the concept of order doesn't matter. When you get your result at the end of it, the order doesn't matter. And if you have a permutation and you get your result at the end of it, the order matters. So if the specific question or the problem indicates that order matters, then we are dealing with a permutation. Whenever you see the word different, most likely it's an indication that you have to use a permutation. When you have the word choose or combinations, then that's also an indication that you have to use a combination. But that can vary. So in this particular question, we know if you play the lottery, you choose between 1 and 50, and you choose a number. Um, the particular order of the number matters. Um, the order of the entire number or the arrangement of the numbers matter. And in this case here, what we're saying is that there's no repetition. So we're removing the repetition from this. By dividing by 6 factorial, we're also removing that repetition. Because a repeated number would be, for example, I choose 44, 45, 46, 47, 48, 49, 50. It's the same numbers, but it's just in a different order, right? So in that case there, we would have to remove that. So by dividing by 6 factorial, we're actually removing all the possibilities of that happening so that we can just have one way, one possible combination of that, of arrangement of those numbers, which comes to 15 million combinations. Yeah, it's a specific set of 6 numbers. Just to go back to that idea of selecting an order. So, for example, if I have AB, right, and I have BA, then we're saying that they are basically one combination. They refer to one combination, right? They refer to one combination because if you had to choose A, B, and BA, because the order in which the object is selected does not matter. The order in which the objects are selected does not matter. It focuses on the selection of objects without regards to order in which they are selected. So we're not regarding the order in which they are selected. So when order does matter, it's a permutation. When order doesn't matter, it's a combination. All right, let's go to the next one. The next one, okay, let me just draw this line. So in the next one, what we have is a combination with repetition this time. Combination with repetition. And again, remember, because we're dealing with combinations, we're saying it order does not matter. And remember, when we say that, what we're actually saying is the order in which objects are selected does not matter. And I maybe should write that down. The order within which objects are selected doesn't matter. Okay. So the equation for this here, the standard formula for a type of question like this would be n plus r minus 1 factorial divided by r factorial divided by n minus 1 factorial. So n is the number of things, the total n is the number of things we choose from. And you choose R of them. So example of this would be if they are, let's say, if they are five flavors of cool drinks, and you have three of the flavors. Okay. How many combinations can you have? So n is 5 and r is equal to 3. In the question, it's good to use some kind of logical reasoning as well, which gets you back to this formula if you can understand how it goes, how it comes back to this. So, for example, well, if I just substitute this into this formula, n is going to be 5 and r is equal to 3. So we know this is going to be 5 plus 3. Let's just see how these numbers and what they mean, right? So if I put 5 plus 3 minus 1 factorial over 3 factorial and 5 minus 1 factorial, then I'm actually getting 5 plus 3 is 8 minus 1, which is 7 factorial, 3 factorial, and 4 factorial at the bottom there. And I mean, this is in particular with repetition where we're using this. We're reducing this by 1, 5 minus 1, but at the same time, we're increasing the top number by um, the n factorial. We increasing it by r and minusing 1. So what happens if I had n factorial over r factorial and n minus r factorial? This would end up as 5 factorial over 3 factorial times 2 factorial. So if there are 5 flavors, so this is on the without repetition, right? So that's without repetition, which is wrong for this one. So if there are 5 flavors of cold drinks, you got 1, 2, 3, 4, and 5. How many combinations can you have? All right, and you have 3 flavors of those. You can have 3 flavors of those, and you want to find out how many combinations you can have of that. So what you notice here is that we're actually increasing the 5 to 7, and then we're repeating that same process where our R has actually stayed 3, and we then subtract from 7 to get 4. But why would we take 5 plus 3 minus 1? If we're choosing R items from N items, where repetition is allowed, and the number of items you are choosing from is essentially unlimited, then the total possible selection possible would be N plus R minus 1. Now, how do they come up with this? How do they even come up with this formula in the first place? You got to wonder, right? It's good to understand it as well and have maybe a bit of background on that. So the number R combinations with repetition allowed multi-sets of R that can be selected from sets of n elements. This equals to the number of ways R objects can be selected from n categories of objects with repetition allowed. What if I break down the formula? Okay, I'm going to break down this formula into its parts, right? So you're going to have 7 times 6 times 5 times 4 times 3 times 2 times 1. And then we're dividing it by 4 times 3 times 2 times 1, because that's 4 factorial. And then 3 times 2 times 1. And we're noticing that those cancel out like that. So you end up with 7 times 6 times 5 divided by 3 times 2 times 1. Does that maybe possibly explain how we choosing? If there are 5 flavors of cold drinks, you have 3 flavors from the 5. All right, so here's an example. Example says, so example number 2. How many solutions does the equation, how many solutions does the equation x1 plus x2 plus x3 equals 11 have? Where, where x1, x2, x3 are non-negative integers. So the solution for this, yeah. So yeah. So each solution corresponds to the way we select. Each solution corresponds to the way we select 11 items from a set of 3 elements. X1 elements of type 1, X2 type 2, and X3 type 3. So here, basically, the order is not important, and it's with repetition. So n plus r minus 1 factorial divided by r factorial. In the denominator, n minus 1 factorial. So not plus 1, minus 1 factorial in the denominator. Yep. And so when we calculate this, we're going to end up with 3 plus 11 minus 1 factorial divided by r factorial, which is going to be, in this case, so 3 factorial and 11 minus 1 factorial. And if you put that on a calculator, what does that come to? I mean, we got 3 plus 11 is 14 minus 1, which is 13 factorial, divided by 3 factorial times 10 factorial. Yeah. All right, so for the examples here, okay, example number one. Mr. Smith is the chair of a committee. How many ways can a committee of four be chosen from nine people, given that Mr. Smith must be one of the people selected? So Mr. Smith is already chosen. So R is equal to 3 and N is equal to 8. And then we take NCR, which is going to be equal to 8 factorial over 3 factorial times 5 factorial. And it'll come to 56 ways. Yeah. So in this one here, we basically stating that order doesn't matter because it's a combination. And we're also using the word choose as well. We're choosing from one, right? We're choosing from n number of items. We're choosing R from n. That's a good indicator that not we're saying that when we're saying the order does not matter. And so we're going to use a combination. But at the same time, we also know that this is without repetition instead of with repetition. Yeah. All right. All right. We'll stop there. Okay.